Hey guys, we are halfway through our conic sections. Today we're going to do 10-4A, which is ellipses. I don't know if you know what an ellipse looks like or not, but an ellipse is just oval shaped. So we're going to do a little intro here, talk you through a little bit of ellipse stuff. It is oval shaped, so it'll often look something like this-ish. That looks a little track-ish. But you will always have these 2 points. We call those the foci. It's just a plural of focus, but it's foci. It looks like foci, but it's foci. Those are fixed points within your ellipse. Really what an ellipse is doing, if you take a cone, okay, conic section, and we do a cross section like this, we get this oval shape. So that's what we're working with here. One thing to know, to understand about this, if I were to pick a point somewhere on my ellipse, the distance to the 2 foci, I just said it wrong, added together would be the same, the sum of them would be the same for any point that we choose. So if I pick this point here, the sum of those 2 distances, so this one and this one, would be the same as the sum of this line with that line. So that's what our foci will be telling us. There's an equation that goes with ellipses. And the equation is this. It will be x squared over a squared plus y squared over b squared equals 1. And that is always what our equation will look like. And this is for when the center is at 0, 0. What we're going to do for all of 10-4 is a center of 0, 0. So you don't need to worry about the center moving right now. Eventually, I think 10-6 we get to a different center. But for today and tomorrow, all we're doing is a center of 0, 0. Okay? So we're going to just talk some basics here. There are 2 types of ellipses. Okay, so we're just going to split this down the middle and talk about those 2 types. So the first one, if we have A is greater than B, right? So up here we have an A and a B. If A is greater than B, here's how this works. If we were to draw an ellipse, okay, notice that A always goes with X, the B always goes with Y. So if you're on your X axis and you move A units, okay, so let's say we went to a point over here and we called it negative A, okay, then the same distance over here would be a positive A. If that distance, so this is the distance A, if that is bigger than B, then my B, let's say we went here, right? This is a length of B, and the opposite direction, this is negative B, would be there. What happens is our ellipse is wider than it is tall, right? So when A is bigger than B, it is wider than it is tall, okay? Our center, like we said, is 0, 0, which will not change for today. And then we will have vertices and what are called co-vertices. It's like the sidekick to the vertices. So when it's sitting this way, our vertices are always the ones that are farthest or farther from the center. So if you look here at A versus B, okay, so this was a length of B and this was negative B. The ones that are farther away are the A's, right? So our vertices in this setup are the positive and negative of A, 0. So really that's 2 points, right? Positive A, 0, which is over here, and negative A, 0, which is over here. Okay, so those are the vertices. And then the co-vertices are the other two, which involve the B's. So our co-vertices on this one are going to be 0, and then we're going up B and we're going down B. So plus or minus B. Okay, those are our co-vertices. So just keep in mind your vertices. These are the ones that are farther from the center. Okay, and then the co-vertices are closer to the center. So closer to 0, 0 and farther from 0, 0 in this case. Okay, then the last two things, and there's kind of one more after that. When we're separating things anyway, we are going to talk about the major axis. Yikes. Major axis and the minor axis. And you can kind of hear it in their names. The major axis is going to be the longer axis. So we're talking about, when we say major axis, okay, major axis here, we're talking about this length. Okay, and if you think about what that length would be, that length is A doubled, right? Because you go A in both directions. So 2A versus a minor axis. And for the minor axis, we're talking about this length. So because we're working from 0, 0, if we just double our B, that would be the length of the minor axis. Okay. Something to note, and this goes for both of them, because eventually, actually no, let's not go there yet. Let's go here. We're going to go to the other side, and then we'll come back to the things about both of them. This side is if A is less than B. Okay, so let's say we draw a picture here. Okay, now our A is going to be our shorter distance. So let's say we go negative A, positive A, and then our B goes further. Okay, notice what happens here if we draw our ellipse. Now it's taller, whereas this other one, it was wider, right? So if we're looking at this, our center is still going to be 0, 0. And then we need vertices. Okay, and remember, the vertices are the ones that are farther from the center. So if we're still talking in terms of A and B here, this is negative A, this is positive A, this is positive B, this is negative B. If we're looking at this, our vertices are going to be the ones that are up and down now. So it's going to be 0, B and 0, negative B. So really 0 plus or minus B. That's two different points, right? 0B and 0, negative B. And then our co-vertices, okay, those ones are going to be involving our A. So that'll be plus or minus A, 0, right? Because that's what's going to give you these 2 points, negative A, 0 and positive A, 0. Okay. Then we need the major axis. And remember, major axis is always the longer one. So my major axis right now is here, which is a length of 2B. And then my minor axis is the shorter one, which would go this way, and that's going to be a length of 2a. Okay, so we have these two setups. The foci. Okay, foci is always going to fall on the major axis. Okay, so if you look at our pictures up here, your foci, these are not accurate perspectives here, but it would be like a point here and a point here, or a point here and a point here. We don't know exactly where they are, but that is where your foci would be. So what you need to keep in mind, and we've kind of talked about this before with circles, was it? Not foci, foci. Oh, that's why I was doing it. From the foci to the center of the circle is a length of c, okay? So from the foci to the center of the circle, or of the ellipse, sorry, is a length of c. Now, the way that we figure out what that c is involving our a and our b, and we have a whole lot of a and b going on up top, right? The setup is this. When we are working with this guy on the left, okay, in this scenario, it will be that c squared equals a squared minus b squared. Looks a lot like Pythagorean theorem, right? It's not, it's close, but basically what you have to realize in this is your foci will be plus or minus c, 0. Okay, so two different points, c0 and negative c0. This, yes, you should know the formula, but you don't really need to know the formula, because all you're really doing with this is you will always take the bigger minus the smaller. Okay, and that doesn't make a whole lot of sense right now because I haven't shown you what we're doing with that, but I will show you that in just a minute and it will make sense to you what I'm talking about with this. Because this formula on the other side looks like this. C squared equals, now it's b squared minus a squared. Okay, so it's just like, how am I supposed to remember which one is which? You really don't have to remember which one is which. As long as you know that you're always doing the bigger minus the smaller, you're fine. Okay, so your foci on this one is 0 plus or minus c. If you think about it, 0 c, this length here is c, whereas over here, this length is going to be our c. So then it would be c 0. Okay. Okay, so that's a whole lot of information. That probably seems a little bit confusing right now because we haven't done anything, but I think once we do it, it will be okay. Here's the deal. We are going to do some graphing, and then we're going to do some working out of equations. So let's start with the graphing. Example number 1. So if you have x squared over 9 plus y squared over 25 equals 1. Okay, this is our equation for an ellipse. Here's what you need to think about. Well, first of all, before we go there, let me just tell you all the things you're going to need to find. So you're going to need to find the vertices, the co-vertices, and this is what we ask you for on tests and quizzes too, is just to tell us all these things. The book doesn't always say list them all. I would list them all because you are going to have to list them for us. And it's really how you come up with your answers, is finding all of these things. The minor axis, okay, and the foci. Okay. Okay, so if we're going to graph this, we're going to start with this. What you need to remember, if you look back to your formula up here, it's x squared over a squared plus y squared over b squared, right? So that means this is a squared, and that means this is b squared. Well, if this is a squared, then a is 3, and if this is b squared, then b is 5, right? We're just taking the square root of both of those. Now keep in mind, the 3 is with your x, the 5 is with your y, and that's how you know where to plot them. So on your x-axis, we are going to go 3 to the right, 1, 2, 3, and 3 to the left, 1, 2, 3. Okay. On your y-axis, our b is 5. So on your y-axis, we're going to go 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Okay, and then you can make your ellipse. I feel like I did not space that out very nicely. I feel like this should be a little lower, but we'll see what it looks like. Good enough. Okay, so think about what that means. Our vertices, remember the vertices are the ones that are farther away from the center. So your vertices here are this point and this point, which are the point 0, 5 and the point 0, -5. Okay, so the way we can write that is 0 plus or minus 5. Now I don't care if you write it as 0, 5 and 0, -5. I'm just trying to save you a step here. Your covertices, those are the ones that are closer to the center. So that's going to be these 2 points, which are going to be a distance of 3. So it's plus or minus 3, 0 for our covertices. Okay. Then we need to know our major axis. And our major axis, I said before, again, if you look here, we're dealing with this one, right? Your major axis is a length of 2b. But now here's what you can really do with that. You don't have to remember that formula. Basically what we're saying is how long is the major axis? Well, the major axis is the longer one. So we're saying how long is this? Well, if we were at the center and we went 5 up and we went 5 down, that's 2 times 5 or 10, right? So you can do 2a, or you can just say, I know that is 10 units. The minor axis then, you're going here with that, and that was 3 units this way, and it was 3 units this way. So that's 2 times 3, or 6 for the minor axis. And then the foci. Remember, the foci always land on the major axis. So our foci are going to land somewhere on this green line here, segment. Our foci are somewhere there. Now, keep in mind, we said we are going to do c squared equals, and if you look up here, it's going to be b squared minus a squared. But again, those numbers are here, okay? You don't need to even remember which one's a or b. You always do the bigger minus the smaller, okay? So c squared is going to equal 25 minus 9, which means c squared is 16, okay? Now, if c squared is 16, we want to know c, so we're going to square root that. Don't forget, when you take the square root, it's plus or minus, not the square root of 4, sorry, we already did that. It's plus or minus 4. So that gives us a foci of, think about where these would be, right? Somewhere here, 4 and -4. Okay, those are our 2 points. So your foci is going to be 0 plus or minus 4, right? The foci is always 0 plus or minus c on these vertical ones. But again, you can see it in the graph, right? You know that point is 0, 4, not 4, 0. So you don't have to remember which one is which of these even. If you can graph it, you can see it, okay? All right, example 2. For this one, we have x squared over 100 plus y squared over 16 equals 1. And I'm just going to do the same type of problem sitting the opposite way. So if you feel like you're good with this, you can skip to the next problem if you want, but I just want you to see what we're looking at here. Okay, so in this setup, if we are going to find the vertices, and we're going to find the co-vertices, and we're going to find the major axis and the minor. Okay, and then we're going to end with the foci. All right, so starting with vertices, remember on the x, we're taking the square root of this. So on your x, you need to go 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so my vertices are going to be plus or minus 10, 0. Okay, my co-vertices, I'm going to take the square root of this, which is 4, and that's on my y-axis. So we're going to go 1, 2, 3, 4, and 1, 2, 3, 4. My co-vertices are 0 plus or minus 4. Okay. Then we need to know how long is our major axis. Well, I'm going from the two vertices. It was a length of 10 and a length of 10, so that would be 20 for my major axis. And then my minor goes from a positive 4 down to a negative 4, which means we're doubling 4. So my minor would be 8. Okay, and then the foci. For this one, we have to do c squared equals, and then it's, remember, the bigger minus the smaller. Those are our squared numbers, 100 minus 16. So we get c squared equals 84. And this one is not a perfect square, which is kind of annoying at times, huh? So we need to put that into simplest radical form. So if you think about this, this is the square root of 21 times the square root of 4. So this is 2 rad 21. Okay, for my c. So technically, if that's my c, my foci then would be, because remember, I never drew my ellipse in. Let me draw the ellipse real quick. My foci are going to be on the x-axis. So it's going to be plus or minus 2 rad 21, 0. And that will be my foci. If you were to plot that, it ends up being somewhere in the 9s. So they're way out here in this problem. Okay, so that's what you're doing there. All right, last type, there's 3 of these, and then we're done. We're going to come up with an equation now. So last they gave us an equation, now we're going to come up with it. So just remember, the equation is x squared over a squared plus y squared over b squared equals 1. Okay, they're going to tell you some information. So for this first one, which is example 3, we're going to say your vertex is 0, 5. You have a co-vertex of 2, 0. And the center, which really doesn't matter because we're doing all 0, 0 right now, but they will tell you your center is 0, 0. And then they're going to say, write the equation of the ellipse. Okay, so if this is our setup, if you think about what this graph would look like, that will help you, I think, to write an equation. So if you have a vertex at 0, 5, that means 1, 2, 3, 4, 5 is one of your vertices. And you have a covertex at 2, 0, 1, 2. Okay, well, we know our center is 0, 0, so that means we have another vertex at negative 5, so down here, and another vertex at negative 2, 0, which is over here. So we're looking at this ellipse, okay? So if we're trying to come up with our equation, and you don't have to graph this, you guys can do this without graphing, but sometimes it might just be easier to see it. It's x squared over something plus y squared over something equals 1. So we need to figure out what goes down here. Well, if you're thinking about it, your x, right, that's what needs to go below our x. Our x went 2 units and 2 units. So we take that 2 and we square it, right, because it's a, whatever the length of a was. This is our length of a. And we square it. So 2 squared is 4. And then our b is this length, and that is a length of 5. So 5 squared is 25. So the equation of this ellipse looks like that. X squared over 4 plus y squared over 25 equals 1. Okay. Example 4. Let's say they tell you you have a center at 0, 0, a height of 18, and a length of 12. Okay, now here's what you need to think. When they're talking about the height, 18 is bigger, so this is your major axis is what they're looking for. And your length would be your minor axis length. So if you were to draw a picture of this, a height of 18, that means you're going up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Because the whole thing, the whole axis here is 18. So cut it in half. And then your length would be 12, so 6 and 6. Okay, so 1, 2, 3, 4, 5, 6. That's not a great ellipse, sorry. So if we're going to write our equation, it's going to be x squared over something plus y squared over something equals 1. So we need to know what a squared is. Well, on our x, this length right here is 6, right? We went 6 units, so we're doing 6 squared. The y squared, if we go here, this length is 9 units, so we're doing 9 squared. So it would be x squared over 36 plus y squared over 81 equals 1. And that would be your equation. Okay, last one. We're again going to write the equation, and this time we're going to do it from a graph. So let's say our graph looks like this. We have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, and 1, 2. Is this a function? It's not a function, right? It doesn't pass the vertical line test. If we go like this, it hits twice, not a function. Just a little fun fact for you. Okay, so if we are going to write the equation of this ellipse, we know our equation looks like this: x squared over something plus y squared over something equals 1. We just got to figure out what those somethings are. So on our x, Our x is going from here to here, a length of 4. So this would be 4 squared. And then this way, a length of 2, so it's 2 squared. Simplest form would say x squared over 16 plus y squared over 4 equals 1. And that would be your answer. That's it.